In the meantime, let me get started. So this is Tutor Tuesday with Dan. If you guys haven't already followed me on TikTok, Instagram, YouTube, whatever, you can check out this link, explore.danstestprep.com, and that's where I post my SAT newsletter that you can sign up for, all my other social media where I have problem-solving tips, and just other helpful resources like practice tests and other articles that I post. It is going to be every Tuesday, yeah. The way this session is going to work is we're going to start with some pretty easy warm-up problems on the SAT. Then we're going to move into some harder math problems, which I found on the ACT. We're also going to do some problems that were submitted by the community, some really tough ones, and then we'll cool off with some easy type problems, which in this case will be some quadratics for this week. So let's go ahead and get started with our first SAT warm-up problem. For those of you who know absolute value, this should be pretty simple. It's asking us, and let me paste it in the chat for people who can't see. Yes, I think there should be Algebra 2 on the PSAT. Okay, so I see some answers already. The question reads that if the absolute value of x minus 10 is equal to 0, what are all the possible solutions to the given equation? Now this one, if you solve it out, there's only one solution. Normally in absolute value, let's say x minus a equals to b. In general, you can expand this out to remove the absolute value and make it the inside portion equal to the right-hand side, or make the inside portion equal to the negative of the right-hand side. Because even if this x minus a was somehow equal to a negative b, the absolute value bars here will make everything positive. So that's what the absolute value bars do. But since this is equal to 0, 0 is not positive or negative, 0 is just 0. And there's only one value of x that will make the thing inside the absolute value equal to 0. And that is x equal to 10. So it should be C. If you tried plugging in negative 10, you just get an absolute value of negative 20, which does not equal 0. If you tried 0, you just get the absolute value of negative 10. But if you plug in x is equal to 10, then you get the absolute value equal to 0. I'm going to paste in the next warm-up problem. This one is saying if the relationship between variables x and y, each increase in in the relationship between x and y, each increase of 1 in the value of x decreases the value of y by 2. When x equals 0, y equals 5. Which equation represents this relationship? So they're all in slope-intercept form. And to get an equation in slope-intercept form, we just need two things, which is one, the slope. And they told us that when x goes up by 1, then y decreases by 2. So if you consider plotting this out, x going over by 1, y up by 2, or sorry, y down by 2, then x over 1, y down by 2, this is a slope of negative 2. Or your rise over run, simply put, is you go down 2 for every 1 over. So here we know our slope is negative 2. That means we can cross off a and b. And then the second part is the y-intercept. That's where the equation intersects the y-axis. We know that when x is equal to 0, right here, the y value is 5. So that's a given. And that means that the answer choice has to be D. Although C has the correct slope, it has the wrong y-intercept. Okay, number 9 here, we got a little simple geometry problem. An isosceles right triangle has a hypotenuse of length 4 inches. Let me actually draw that out here so it's a little bit easier to see. An isosceles right triangle. Isosceles just means that two of the sides are equal to each other, the same. And I'm going to mark that with these blue tick marks. And then the hypotenuse is the longest side. So that's here. Let me highlight isosceles in blue. Hypotenuse is the longest side. That would be opposite the 90-degree angle, because that's the widest angle that we can have in this right triangle. The hypotenuse is equal to 4 inches, and we want to find the total perimeter. Well, I know that if I have an isosceles right triangle, let me just flip this upright for a second. It's the same thing as a 45, 45, 90 triangle. You have to have, if it's isosceles and these two sides are the same, the two angles have to be the same as well. And for an isosceles right triangle, that's a 45, 45, 90 triangle, if the base is x, then the hypotenuse is x root 2, because you can think of, if you want to derive this yourself, you can think of applying the Pythagorean theorem, and instead of a and b, you just put x. Which means that if this hypotenuse is equal to 4, we can back calculate x. So if x root 2 is equal to 4, that would imply that x is equal to 4 divided by root 2. And since I don't see anything in a denominator in these answer choices, I'm just going to rationalize this. The way you can do that is by multiplying 4 over root 2 times the square root of 2 over square root of 2. Right? Because the square root of 2 divided by the square root of 2, or divided by itself, that's just equal to 1. So I'm not changing the value of anything here. I'm just rewriting it in a different way. And then if I multiply across and simplify, I get that x is actually equal to 2 root 2. So the total perimeter, we just have to add everything up, perimeter, and that would be the hypotenuse of 4 plus the side length of 2 root 2 plus another side of 2 root 2. And that would be 4 plus 4 root 2, which should be answer choice C. Hopefully that one's all clear. And the last one is actually the last in the no calc section. I really like this problem because it's a interesting way to look at a concept that you guys probably already know. See if you guys can recognize what we're talking about, and then I might go back and explain the previous question. But here we have x squared plus bx plus c equals 0, and b and c are constants. If negative b plus the square root of b squared minus 4c equals 18, and negative b minus the square root of b squared minus 4c equals 10, what is one possible value of x? That looks like a whole bunch of nonsense, maybe, but to me this actually brings out a special pattern, and that is, if you remember the quadratic formula, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Here we have something similar. We have negative b plus the square root of b squared minus 4c. All that it's missing is this divide by 2a and the a term in here. But if we look here, we notice that our a term equals to 1. So really all we're missing, and I'm going to draw it in a lighter blue here, is this divide by 2. So if we want to equate this, we can go ahead and write it like this. Negative b plus, or let's take this equation right here and rewrite it to include the whole portion of the quadratic equation. Negative b plus the square root of b squared minus 4ac all over 2a. But remember, a is equal to 1, so this is just going to simplify to 4c over 2. Since I divided this side by 2, I'm going to divide the other side by 2 as well, right, to keep the equations balanced. So in total, this means that if you have this part of the quadratic equation, you divide this side by 2 and this side by 2, one of the solutions is going to be equal to 9. And you could do the same thing with the other part of the equation they gave you. If you convert it to match the quadratic formula by dividing by 2, you could get another solution for x, which would be x is equal to 5. So your two solutions for this are going to be x is equal to 5 or x is equal to 9. Does that make sense, everyone? Let me go back to the other problem because I know we had a couple questions on this one. So I'll briefly run through it again. This one is telling us we have an isosceles right triangle. That just means we have a right triangle with two sides being equal to each other, and those I've marked with these blue hash marks. The hypotenuse, or the longest side of the triangle, has a length of 4 inches. So that would be this side opposite of the right angle. That's the widest angle. To find the perimeter, we can use the fact that this is a 45, 45, 90 triangle, meaning that if these two sides are equal to each other, the angles must be as well. So they must be 45-degree angles up here, 90-degree angle right here to satisfy the right triangle. And then if we just name one of the sides as x, we can calculate the hypotenuse as x root 2. And you can even get that using the Pythagorean theorem, or something like x squared plus x squared is equal to c squared. That would mean 2x squared is equal to c squared. And if you divide by 2, or sorry, you don't even need to divide by 2, you just take the square root here. You get c is equal to the square root of 2 times x, or x times square root of 2. So that's how I got this hypotenuse right here. And since you already know the value of the hypotenuse, you can just plug in 4 onto the other side of this equation. You can back solve for x. And now once you have the hypotenuse, plus these values of 2 root 2, you just have to add everything together to get the perimeter. How to go about a question like this? Yeah, we can get to that at the end if we have some time. That one looks interesting. Let me move on to some of our community submitted questions. I noticed some of these are from the AMC math exam, and they're a little bit more interesting, or I guess just different than some of the SAT problems. So these should be a little bit harder. This one says that the sum of three numbers is 96. The first number is 6 times the third number, and the third number is 40 less than the second number. What is the absolute value of the difference between the first and the second numbers? Okay, so it won't do us much good to write something like a plus b plus c equals 96, just because we have three variables and one equation. So I would write this sort of like if the first number is a, that's 6 times the third number, which is c. Let me write it here. A is the first number, b is the second number, and c is the third number. So something like a equals 6c, that's the first number is 6 times the third number. We have something like, or even we want to get this in one variable, so let me actually erase this. Let me just call the third number as x. Then the first number is just 6 times x. And then the third number, x, is equal to 40 less than the second number. So if the second number is something like y, the third number x is just 40 less than the second number. So that means the second number would just be x plus 40. And then if we want to add those up, the first number plus the second number plus the third number, that's going to get us 6x plus 40 plus x is equal to 96, you just have to simplify it from here. So you get 8x plus 40 equals 96, or 8x equals 56. And somewhere I might have made a math mistake. Eight x equals 56. The number is 40 less than the second number. Oh, no. That just means x equals to 7. And that's not the final answer. We want to get the difference between the first and the second numbers. Let me do that in green. Difference between the first and the second numbers. Well, the first one is just 6x. The second one is x plus 40. So that would be 42 minus 47. And the absolute value of that is going to be 5. So the answer for this one should be E. Seems like some people can't see. Okay. Let me go on to the next one. I see a lot of people maybe can't see the screen, so if that continues, maybe I can stop sharing my screen and reshare. But I will share the question for this next one. This one is another fun one that I saw someone post in the math chat today. It says that if alpha and beta are the roots of the equation x squared minus 6x minus 2 equals 0, then evaluate alpha to the 100th power minus beta to the 100th power minus 2 times alpha to the 98th power minus beta to the 98th power, all over alpha to the 99th minus beta to the 99th. Right now we're just doing some community questions, and after this we'll move to the ACT, but we just did our SAT in the beginning. So for this one, we have x squared minus 6x minus 2 equals 0. That's our original equation. If alpha and beta are the roots or the solutions, that means I can substitute something like alpha in place of x. And that would mean that instead of x, I'll just put alpha squared minus 6 alpha minus 2 equals 0. These are some pretty large numbers, so what you can do here to get these powers of 98 and 99 and 100 is actually you need to multiply this whole thing by alpha to the 98th power, and that'll give you exactly what you need out of there. If I multiply this whole thing by alpha to the 98th power, I'll get alpha to the 100th minus 6 alpha to the 99th minus 2 alpha to the 98th equals 0. It's still 0 because multiplying anything by 0 will keep it at 0. So here you might be able to see where these 99, 98s, and 100s can pop into the equation. And I can do the same thing with beta. So I could say like beta squared minus 6 beta minus 2 equals 0. And then I would get something like beta to the 100th minus 6 beta to the 99th minus 2 beta to the 98th when I multiply by this factor of beta to the 98th power. Then what I can do is if I have this equation 1 and I have this as my equation 2, I can take equation 1 minus equation 2. So I could do something like alpha to the 100th power minus, actually let me just write this whole thing, 2 alpha to 98th. I'm going to subtract this whole second equation, which I'll just rewrite right here. Now I can distribute the subtraction. This is all still equal to 0, by the way. Alpha to the 100th minus 6 alpha to the 99th minus 2 alpha to the 98th minus beta to the 100th plus 6 beta to the 99th plus 2 beta to the 98th equals 0. Or I can start to combine some of these terms a little bit closer, and I can move alpha to the 100th minus beta to the 100th together. And then I could do subtract 2 alpha to the 98th plus 2 beta to the 98th. And I can move this powers of 99 to the other side. So I can get like 6 alpha to the 99th minus 6 beta to the 99th. And finally, let me just try to match it more to this form right here. I'll get alpha to the 100th minus beta to the 100th minus 2 alpha to the 98th minus beta to the 98th equals 6 times alpha 99 minus beta 99. And if we just divide by this alpha to 99 minus beta to 99, you can see that we've successfully rearranged it into this form right here. And what we found is that it's just equal to 6. Without having to evaluate these 100 powers, 99 powers, 98 powers, then we got this whole thing equal to 6. Let me reshare my screen and see if that fixes the problem for you guys. Let me know if you can see this. Give it a minute. Fixed it? Okay, nice. Let's move on to our last two of these harder AMC math problems. Here's one in the chat. Emily sees a ship traveling at a constant speed along a straight section of river. She walks parallel to the riverbank at a uniform rate faster than the ship. She counts 210 equal steps walking from the back of the ship to the front. Walking in the opposite direction, she counts 42 steps of the same size from the front of the ship to the back. In terms of Emily's equal steps, what is the length of the ship? Okay, so let's just start defining some variables here. So we could do something like x is equal to length of the ship. And we can think about the scenario of moving forwards first. While we're moving forward, the ship, or Emily moves 210 steps. Emily moves by 210 steps. And the ship moves 210 minus x steps. So we can draw this out sort of like here's a top-down view of the ship. Here's Emily. They're both moving in this direction, but the ship is moving a little bit slower. So while Emily moves over to here, 210 steps, the ship, let me do it in a different color. The ship may still be like right here, while Emily is in her new position here. Now, in the time that she's walking back to the ship, or sorry, let me draw this better. When she walks from the front of the ship to the back of the ship, they're both going to end up at the same position, right here. And then when she walks back, let me do that in green. Back. Emily moves 42 steps from the front to the back. Okay. And the ship moves by 42 minus x, or sorry, x minus 42 steps. So we can create an equation now. We know that she's traveling at a uniform rate, right? Uniform rate, which means that her moving forwards and moving back is the same speed. So if she moves 210 steps forwards while the ship moves 210 minus x, then that's the same rate as she moving 42 steps back and the ship is moving x minus 42 steps. If we want, we can just cross multiply this, and actually, since 210 is a multiple of 42, we can even simplify this before cross multiplying. If we divide by 42 everything, 42 times 5 is 210, so we'd get 5 over 210 minus x is equal to 1 over x minus 42. Cross multiplying, we'd get 5x minus 42 equals 210 minus x. And this would give us 5x minus 210 is equal to 210 minus x. Or 6x equals 420, which means that x equals 70. And that would be answer choice A. That one makes sense to you guys? Questions? How I got the equation? Yeah, I can explain. So, if you think about this one, the rate at which she's walking and the ship is moving, they're both going at a constant speed or uniform rate. So if I can find the ratio of Emily to the ship moving forwards, that's the same as the ratio of Emily to the ship moving backwards. So all I did was just counted the number of steps that they're traveling to get the ratio of how fast they're traveling. Or it tells you here that moving forwards, Emily moves 210 steps walking from the back of the ship to the front. In that same time, the ship did not move 210 steps, right? Let me draw this out on this diagram right here. Emily moved from here to here. Let me maybe do it in like a different color. Or from this light blue to this cyan color. Emily actually moved 210 steps because she moved all the way from the back of the ship to its front, or where its front would be as it was cruising along the river. But the ship, if you measure it from the back reference point, it did not move the full 210 steps. It actually moved 210 steps minus its length, which we called as x. Right here is, if this portion is 210 minus x, this portion is x. In total, these two will sum up to 210 because that's the number of steps that Emily went. But just counting the number of quote-unquote steps that the ship has moved forward, it's only moved forward 210 minus x, whereas Emily moved the full 210. Then I can put that as a ratio here, or the ratio of Emily's steps to the ship's steps, and that will give us sort of kind of like a speed. And I just do the same thing moving backwards, right? Except moving backwards, she moves 42 steps, while the ship has moved x minus 42. We kind of flip it going backwards. Make sense? Awesome. I think we have one more AMC math problem. Let me paste it in the chat for people who can't see the screen. Elmer the emu takes 44 equal strides to walk between consecutive telephone poles on a rural road. Oscar the ostrich can cover the same distance in 12 equal leaps. The telephone poles are evenly spaced and the 41st pole along this road is exactly 1 mile from the first pole. How much longer in feet is Oscar's leap than Elmer's stride? It's an interesting problem. So if we have the first, let me draw this out. We have the first telephone pole. We have the second one, third, and so on until we get to the 41st pole. So it might help us to first find the distance or the gap distance between two consecutive telephone poles. Now I know if there's 41 poles, then there's actually 40 gaps, right? 41 poles means that we have 40 spaces between them, or 40 gaps, right? Because if you consider the simple case of 3 poles, you have 2 spaces in between them. There's always one less space than there are poles because you need the final pole to kind of block that space off. So, 3 poles means 2 gaps. We can extend that idea, keep going, until we get to 41 poles and 40 gaps. So that means between each gap is the 5,280 feet divided by 40 gaps. If you divide that out, you could probably do this in your head with the 5,000 divided by 40 is equal to 200, and then the 280 divided by 40 is going to be 50. Hold on. That's not right. 5,000 divided by 40 is going to be 125. And then the remaining 280 feet divided by 40 is going to be should be 7. So I just split up the work between dividing this whole thing, or you could use a calculator, and you'd get there's 132 feet per each gap. 132. How much? So 132, that's what we got so far for the gap distance. 132, let me write it, 132 feet. Now, if Oscar covers, let me do it in a different color. For Oscar covers 132 feet in 12 leaps. And that means he covers 11 feet per each leap. For Elmer, the emu, he covers 132 feet in 44 strides. So 132 divided by 44 is going to be 3 feet per stride. And if we're trying to find how much longer is Oscar's leap than Elmer's stride, that's just going to mean the difference of the two. It's going to be 11 minus 3, which is 8. 8 feet. I see some people already put 8 feet as the answer. That's very good. Very nice. Okay, let's move up to some ACT math problems, since this is mostly like SAT and ACT. This one is similar to kind of like an AMC math problem though. It's saying the sum of two positive numbers is 151. The lesser number is 19 more than the square root of the greater number. What is the value of the greater number minus the lesser number? Okay. So two positive numbers is 151, so x plus y, I could say, is 151. And then the lesser number, let's just arbitrarily set that as x. The lesser number is 19 more than the square root of the greater number. Okay, now that I have these two equations set up, that's basically all I need to solve for this equation. First things first, I probably want to convert this equation to isolate the square root of y, or x minus 19 equals square root of y. Because then what I could do there is I could square both sides, and I could get y is equal to x minus 19 squared. Or I probably want to expand that out, right? So y is equal to x squared minus 38x plus 19 times 19 should be 361. And then now that I have this alternate definition for y, I can substitute it back into the original equation. And I can get x plus, let me draw it in black, x plus x squared minus 38x plus 361 equals to 151. And then if we simplify that, we're going to get x squared minus 37x plus 361 minus 151 is going to be 210. Okay, so this one you should be able to factor it. And what I can see pop out at me are the numbers 30 and 7. 30 and 7 could add up to 37, and it could multiply to 210, which would make an equation factorable like this: x minus 30 times x minus 7. And that could give us two solutions as x equals 30 or x equals to 7. Now, what did I say? I said that the lesser number, in our case, I think I said the lesser number was x. Lesser number equals x, and then the greater was y. Let me just say that x is equal to 7 to start. If x is equal to 7, then y is going to be equal to 151 minus 7. We get y equals 151 minus 7, which would be 146. And then the value of the greater number minus the lesser number would be 146 minus 7. But that's not really on the answer choices. So it must mean that our actual answer should be with x equals 30. If x equals 30, then y equals 151 minus 30 equals 121. And then the value of the greater number minus the lesser number is going to be, let me do it in a totally different color. Oh, I don't like yellow. Y minus x equals 121 minus 30, which should be 91. Yeah, 361 comes from the 19 squared. That one was ended up being a little bit messy. I had space down there. But the lesser or the greater number minus the lesser number would be 91. Here's another fun ACT problem. The list of numbers 41, 35, 30, x, y, and 15 has a median of 25. So that means the middle number, if they're organized from least to greatest, that would be the median. The mode of the list of numbers is 15. That's the most common number. Let me do like this: median equals middle number. The mode is the most frequent. And then to the nearest whole number, what is the mean of the list? Well, the mean is the weighted average. First, let me look at the median and the mode. The median is 25. So if I organize this from least to greatest, I already have these numbers that are above 25. So I need these numbers to be below 25. So let me organize it like this. We have 15, x, y, 30, 35, and 41. I know that there has to be at least one other 15 because that's what the mode is. That's the most frequent number. So I'm going to say 15, 15, y, 30, 35, 41. And then I know that the median is 25. Median is 25. In a list with an even number of items, the median or the middle number doesn't exist as a single number. You take the average of the two most middle numbers. In an odd numbered list, you would have an exact median, but here I need to take the average, which would mean that y plus 30 divided by 2 would equal 25. In order to get an average value of 25 in here, I need y to equal 20. So I'd get 15, 15, 20, 30, 35, 41. And now to get the mean, you just have to plug this into a calculator. It would be all of these things added up, the values of each, and then divide by the number of items that you have, which is 6. So the mean, if I do this on my calculator real quick, is 15 plus 15 plus 20 plus 30 plus 35 plus 41 divided by 6. And that equals 26, which is C. Oh, someone got 27? Let me check my work again. So we have 15 plus 15 plus 20 plus 30 plus 35 plus 41 divided by 6. I am still getting 26. Add up all the numbers, divide by 6 to get your mean, and then you get 26. If you guys are getting these numbers, it should be 15, 15, 20, 30, 35, and 41 divided by 6, and this should add up to 156, which when you divide it by 6 will get you 26. Alright, maybe we can come back to that one. Let me move on to these next ones though. This one is a system of equations where r, s, and t are integers. For which of the following will there be more than one xy solution with real number coordinates for the system? More than one solution. More than one solution. That kind of rings a bell for me in quadratic equations and using the discriminant to find out where we're going to have more than one real solution. Also, I have this definition that y equals sorry, I think my mic cut out. I have this definition, y equals x squared. I can substitute that into the bottom equation. Or I'll get rx plus s x squared equals t. I can further rearrange that to get x squared, or sorry, sx squared plus rx minus t equals to 0. Now in a quadratic, if you've ever heard of the discriminant, this is a value that can tell us how many solutions a system has, or a quadratic has. The discriminant is defined as b squared minus 4ac, and it's the part underneath that square root in the quadratic formula. If b squared minus 4ac is greater than 0, that implies we have two solutions. So I'm going to try to get the discriminant of this whole thing right here so I can get two or more than one xy solution. So if I apply that discriminant formula, taking my a, b, and c coefficients here, and let me plug them into the formula, I'll get r squared minus 4s times negative t is greater than 0. Or r squared plus 4st is greater than 0. That should be answer choice F. Questions on that one? F, yes, F is correct. And there's one more ACT problem right here. The third and fourth terms of an arithmetic sequence are 13 and 18 respectively. What is the 50th term of the sequence? Okay, so you can tell, let me see, if I make a table here, it'd be easy to see. If we have term number 1, number 2, 3, 4, 5, and so on until we get to 50. We have these values filled in already for term number 3 is equal to 13, term number 4 is equal to 18. You can see for every change in 1, we add 5. but it would be kind of a lot to fill out the full table where we have, uh, we go to term 5 and we say, oh, plus 5, that's going to be 23, and so on. Instead, what we want to do is find some kind of pattern or formula that we can apply here, or maybe some kind of equation that we can even use. And what I see here is, if I make this 1 even higher, I could have, let me move everything down here. So in my table, I have the terms on the left side and the corresponding values on the right side. What I could do, or what I would like to do here, is put this into kind of an equation, like y equals ax or mx plus b, because it looks like it's linear, right? Every time we go up 1 on the term, we go up 5 in the value. So that would mean we have a slope of 5, and we just have to find the intercept, which is when we're on term 0. And if we back calculate subtracting 5 every time, we get that the value of the 0th term is negative 2. So we get something like y equals 5x minus 2. And if you plug in something like, let me do it in green. If you plug in a value like 3, you get y equals 15 minus 2, y equals 13. You can verify that your equation is correct. This is definitely the equation to use. So if we just want to find the 50th term, we just take our equation, y equals 5 times 50 minus 2. We get y equals 250 minus 2, or y equals 248, which is A. (46 times 5 plus 18 was another formula that was offered up, and that would also work because you see, in order to get from the 4th term to the 50th term, we have to go another 46 times 46. And since we already started at 18, we just need to do, let me write that here, could also do 4 times 46 plus 18. It actually doesn't really matter your start point as long as you know the number of progressions to go further. So this would also equal 248. The equation that I derived was y equals 5x plus, or 5x minus 2. Or even better to write it would be something like f of x is equal to 5x minus 2. Because then you could say like the function at the 50th term. Yeah, 5 times 50 minus 2 works. Okay, so we've done a lot of math problems here. Before we go into our last couple of problems, which we may have time for a couple of them, I want to remind you guys to check out my Explore page where I have more tips for solving these kinds of solving these kinds of problems. I also have videos on my TikTok and YouTube that detail problem solving tips. And each week I send out an SAT and ACT newsletter. And I'm going to write about the digital SAT upcoming soon. But this was a problem sent in by a student that I found kind of interesting. It's the quadratics and how we can use them to model real-world problems. So let me make sure everybody can see this in chat. In science class, the students were asked to create a container to hold an egg. They would then drop this container from a window that's 25 feet above the ground. If the equation of the container's pathway can be modeled by the equation h equals negative 16t squared plus 25, how long will it take the container to reach the ground? First, it asks us find the maximum height of the container, and then in how many seconds will it reach the ground. So take a second, think about this, and see if you guys know how to solve this. So for the maximum height, what I would do personally is, okay, yellow will show up pretty nice here. Maximum height, or for a quadratic that's facing downwards, I would just find the vertex. And the vertex is at negative b over 2a. X equals negative b over 2a. So, to find the vertex, I could do, oh, that's a kind of ugly color. X equals, negative, there is no b term here. So, the vertex actually is at x equals 0. And when, or t equals 0. And when t equals 0, then h is equal to negative 16 of 0 squared plus 25, or the height is 25. That makes sense. In this equation, it's actually symmetric about the origin, which means they kind of just threw it like that. They didn't throw it upwards at all, they just dropped it. So yeah, the maximum height is 25. And how many seconds would it take for the container to reach the ground? That one we can actually solve when h is equal to 0. Right, h is equal to 0 means that 0 is equal to negative 16t squared plus 25. That becomes pretty simple because there's no b term, which means that we can just move this negative 16t onto the other side, like so, giving us 16t squared is equal to 25. Divide by 16 to get t squared is equal to 25 over 16, and then take the square root to get t is equal to 5 over 4, or 1.25 seconds. Hopefully that one's all clear. Oh yeah, there's the reference sheet for the paper SAT. 5/4, yes. That egg is dead, unless their container was really nice. And then these last two problems I think we can do really quick. This is just solving for x in a quadratic equation. The method I'm going to show you guys specifically is completing the square, because I think that's a method that not a lot of people use very frequently. So I'd like to demonstrate how you could do that. In this equation specifically, what I would do first is simplify all the terms to get it an equation equal to 0. So I'm going to move the 6 onto the other side, or get 5x squared plus 10x minus 40 equals 0. All I did was just subtract 6 on both sides. And then I can divide by 5. Let me do that in a different color. Divide by 5, and I get x squared plus 10x minus 40 equals 0. Of course, you could try to factor this one, but if we were wanting to complete the square, it would be beneficial for us to first rewrite it such that the constant term is on the other side. So x squared plus 10x equals to 40. Then what I want to do in order to complete the square, I'll write this here, completing the square. When we're completing the square, we're trying to find some constant term that we can add to both sides that will make the left side a perfect square. So I'll show you what that looks like. And we're actually going to add this term to both sides. Now to find that term, there's actually a very specific way that you can do it that will get you the right answer every time. You take the b term, or you take the term that's associated with an x. That coefficient is 10. You take half of this coefficient, you square it, and you add it to both sides. So that would mean half of it would be 5. 5 squared would be 25. And you add that into both sides. It's a very specific form. And what you'll find is that you'll get, sorry, I forgot to divide this 40. So this should actually be 8. And I forgot to divide the 10 as well. This should be 2. Dang. Well, that makes it a lot simpler, actually. Completing the square, let's try that again then. Half of the coefficient, which we now know is 2, that would be, half of it would be 1, and 1 squared is just 1 again. So if we add it into here, we just add 1 to both sides. And now when I rewrite this equation, x squared plus 2x plus 1 equals 9, what I can do is rewrite this as x plus 1 squared. What I've just done here is completed the square. So I found the constant term here that when I add it, I can now factor this as a perfect square, as a perfect a plus b whole thing squared. And now since this is real easy for us to square root, we are going to get something like x plus 1 is equal to plus or minus 3. Once we take the square root of this side, we get rid of the square. Once we take the square root of this side, we just get a plus or minus 3. And from here, you just get two solutions, right? You get x plus 1 equals 3, which means that x is equal to 2. Or you get x plus 1 is equal to negative 3, meaning x is equal to negative 4. So these would be your two solutions. X is equal to 2, x equals negative 4. And the last one here, this one is a little bit harder because some of the terms will be irrational. But maybe you don't want to use the quadratic formula, you want to use completing the square. Then this is how you do it. You could take, first simplify everything. I'm going to divide everything by 3. Divide by 3, divide by 3. This becomes x squared minus 2x minus 1 equals 30. Remember, I want to move all the constants onto one side, so I get x squared minus 2x. And then I'm just going to leave the empty space for our mystery term. Equals 31. Again, the mystery term here is just going to be 1. So we get something like x squared minus 2x plus 1 equals 32. Or I can factor this as x minus 1 squared equals 32. So now when I take the square root, I will get x minus 1 is equal to square root of 32, which by the way can be simplified because we know that 32 is equal to 16 times 2, and the square root of 16 is just 4, so this becomes a 4 root 2. X minus 1 equals 4 root 2. Remember to add the plus or minus when we take a square root of an equation. And then we get our two solutions, which are x is equal to 1 plus 4 root 2, or x is equal to 1 minus 4 root 2. That was pretty quick and simple for us to do, and we didn't have to apply the quadratic formula. And then you can just check. Yeah, you can check with the quadratic formula. Is that all clear to everybody? Alright, cool. We'll end off there then. Thank you guys for attending this session. Don't forget more resources at my explore.danceTestPrep.com page. And I'll post a PDF of this and hopefully the recording soon so you guys can review any of these problems. Yeah, thanks for joining. See you guys next week.